This is lesson 10.2, and we're looking at measures of angles and arcs. The first kind of angle we're going to talk about is the central angle, and it is an angle whose vertex is at the center of the circle, with sides being radii. So an angle whose vertex is at the center of the circle. I always think of a piece of pie or a piece of pizza, how we cut those from the center. So slice. So if we kind of look at our circle, we have our usual right angle marking there, so that does mean 90. A circle itself, if you recall, is 360 degrees. So if we have 120 and we have 90, we are going to subtract those to figure out what's left for x there, which would be 150 degrees. So over here for this one, this is a diameter, which means we have 180 for kind of this half of the circle there. So we're going to add all of those pieces up, which would be adding the 75, the 5x minus 5, and the 7x plus 2. And that's going to give us 12x plus 72, and that's going to equal 180. So 12x is going to equal 108 when we subtract our 72 from both sides. So dividing by 12 is going to give us x is 9. And we don't have to plug it back in because it says find x, and we did. So a little more vocab down here. An arc is the outside curve of a circle. And the measure in degrees, just like when we measure the angles, the arcs are also in degrees. And a minor arc is going to be the shortest arc containing or connecting two endpoints. The major arc is going to be the longest arc connecting, kind of the longer way versus the shortest, connecting those two endpoints, whichever ones they tell us. So for example, like PTR. And so for example, a minor arc would be like PR. It's the shorter distance, and then the longer distance, the blue, connecting P and R would be the major arc. And then the semicircle, we kind of talked about above, the arc with endpoints. We called it a diameter though. Endpoints that lie on the diameter. So 180 degrees. It's a semicircle. So we're going to label our stuff here. So XZ, that arc right there would definitely be a minor arc because it is the shortest distance. And we can kind of also think of like if it's less than 180, usually it's your minor arc, and more than 180 is your major. But next we have XY, Z. Did I go the right way? Yeah. X, Y, and then Z. And it kind of tells you like go from here to that one to that one. So yeah, that's definitely a major arc there. Next up is XWY. That would be a semicircle. I don't know if we're labeling it major, minor. The other one's WXZ. So WXZ would be a minor, because a major would be going this way, and that would be bigger than 180, so that would be a minor. A little tricky on that one with the 3 letters, right? So we got to pay attention. Then WZX going that way, so that's definitely major. And if you want to try that last one there on your own, and pause the video and try it. And hopefully you got minor arc. I put mirror on that one too. There we go. I can spell. All right, so congruent arcs. Just like what you might think, they are arcs that have the same measure or length. We're going to talk about length here in just a little bit, but adjacent would just be arcs next to each other. Kind of like when we talked about adjacent angles, we can have adjacent arcs next to each other. So we're going to go ahead and find the degrees here. Again, thinking of 180 for kind of our half. Whatever our inside angle is, our arc is that same measure when it's at the center. So for example, if this one's 36, then x. That arc measure is the same as its central angle. So this would be 180 minus the 36 here to get your y, which is 144. And then z is a semicircle, so that's 180. So in this one, we can go ahead and label B. It's across from that box, which we know is a right angle, so 90 degrees there. We know 41, so A is going to have to be 41. And then we can find E, because again, these three form a semicircle. So 180 minus our 41 and minus our 90 is going to leave us with E, that angle here, which is the same as the central angle. So that is 41 degrees. 49 degrees. There we go. So, and we can write things in. It does help when you get different values to kind of put them in there. So here again is a semicircle, 90, 49. So this would have to be 41 to get to 180, since we know it from this direction. So that means that C and D are both 41 degrees. And then we have what's left when we take 180 minus our 41 to get this angle, which is going to be our F. So 139 degrees when we subtract there. So we can actually add arcs together that are adjacent to each other. So for example, we could add CE and we could add ED, and it would be arc CD, or CED if you want to use all three letters there, because it is a major arc. But we get that entire arc when we add the two kind of smaller arcs. So here we're going to find LHI, so this little section here, which it looks like, I go the right way, LHI, yes, that if this is 90, then this right here, that's 90 degrees, because they form a semicircle. And then we have our I, J, K. So this section right here. So we want to figure out what that is, which we know from H to K, that's 180, but we don't have this little 32 degrees. So 180 minus 32 degrees is going to give us 148 degrees, which will be our arc right there. So the last thing we're going to talk about is arc length. So the actual length of that arc. So not degrees, because arc measure is in degrees, but arc length is measured in units. So it's an actual length. So for example, like centimeters or meters, and so on, those length measurements, inches. So here is our formula. Our equation is taking our degrees and putting it over 360, because we need to know what portion. So 45 degrees out of the 360 total is this little section here. And then we're going to take that times our formula for circumference, which is 2 pi r. So 2 pi times our radius, which we have here, is 3. So we are going to use our calculator and put our 45 divided by 360 in parentheses, so 45, or parenthesis 45 divided by 360, close parenthesis, times 2, and then our pi button, and then times 3, and then hitting enter, and we should get 2.36 centimeters, which is the length of AB. Okay, so that is the length. So we don't use the M in front, we just use AB, the arc over it. So no M in front for measure because it's not degrees. So for this one, I want you to go ahead and do this one. Go ahead and put your degrees. Again, we're finding AB on this one as well. So it's across from, there's your 80. So put your degrees over 360 and then take it times 2 pi, and then our radius, make sure that you get radius, not diameter, because 14 is the whole length. And we only need the radius, which is going to be half. So go ahead and type this into your calculator and check your answer with what I have. And double check that you got 9.77, and this is meters since it has meters right there for the units.